Hello, 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 everybody, and welcome back. I hope you guys are having a good time, or as good as can be during these times. Let's go ahead and get back to our class here. Real quick, what have I been up to? Uh, I'm ashamed, but I did make this really large boat. It's very big. It's a boat. Uh, Here you can see my beautiful sheep getting sheared automatically. It's it's really not a good look. Uh, and got this lift here, takes you up into the boat. Yeah. Um, I want to go back to work, please. Anyway, let's talk about what we're doing in computer science. Once again, we are getting into the create task. Before I talk anything else here, I do want to reiterate, I cannot answer direct questions about problems you're having with your actual code or responses. All I can do is answer general questions. So if you're not sure why your code doesn't work, you can go to your classmates for that. You cannot collaborate with anyone on your written responses. So just to reiterate that real quick. What are we doing this week? We're going to go over those problems you guys did for me from last week, just so that we're all on the same page for those. And we'll talk about how to plan for it, and we will start the project. You will be responsible for doing hours 1 through 4 by the end of this week. So that means you need to put in about 4 hours of work. Do this Sunday, just a single check-in where you're going to show me the code you've written so far. I'm not going to give you direct feedback on it because I can't, but I will give you 5 points for putting in something. Hopefully it's code that you put in. And then what I will do is if there are some trends that I'm seeing or some really obvious things that could benefit everybody, I could mention them for the whole class. That would be allowed. I can't give you individualized feedback though. All right? So please make sure you do that. All right. So let's go over some of the exercises from yesterday. This first one got deleted, but it was real bad, so we won't worry about it. The second one right here, is it an algorithm? So remember, we're looking for 3 things here. There's at least an algorithm with 2 or more algorithms inside of it. One of the included algorithms, one of the 2 smaller ones, has logic or mathematics in it. And you can explain how one of the included algorithms works by itself. So let's go through and take a look. This right here, I mean, technically an algorithm, but no included algorithms, no math, no nothing. So this one's bad. Let's look at this one. So here we have a large algorithm that calls 2 smaller ones. So we're almost there. But look, the math or logic in this case, the comparison, happens in the main algorithm. This does not work for that point. Okay, you will not get the credit if your comparison is in the large algorithm instead of one of the smaller ones. Now, you can still have this in the large one. There's no reason you can't, but one of your smaller ones still needs either math or logic in it somewhere. So this doesn't work. This one right here is real good. So if you're looking for an example of how to do it, this one would get all the points. Notice the way it's laid out. You have a function for one of the smaller algorithms. You have a second function for the other one. This other one has some math or logic in it. And then you have a third function that calls these 2. That makes it really easy to follow and easy to write about. Let's look at number 5. This would qualify, but the way it's set up, it's a lot more difficult to write about. You could say that this whole thing is one big algorithm, and then you could say this first bit here is one small algorithm, and the second bit is another small algorithm. And if you write about it well and make that distinction really clear and explain what each part here does and how they're distinct, you can get full credit. But it's hard to read. So you can do this, and you'll be okay. But I highly recommend this setup. It's a lot easier to work with. Just write a function for each separate algorithm. Easy. Let's look at the abstractions now. So the abstractions we've talked about need to have a student-developed abstraction. It needs to manage the complexity of your program in some way. Well, anything that's on event is out, right? Look at this. No on event. So if you see on event inside the box is wrong. Real easy. Wrong. 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 Okay. So here we have on event, and it calls the set button pops. This would actually qualify. Now you might say, well, this distinction is arbitrary. I could have just as well had this code inside here. Yes, you're right. What the AP board is looking for you to do is to show that you understand that you can write a function like this and then call it different ways. So really, it would be a lot easier for you to show managing complexity, this section here, if you call this more than once. If you just call it once, it's a hard sell, right? Like this probably works as an abstraction, but it doesn't manage complexity very well. For it to manage complexity, you'd want to call it somewhere else, or maybe have a parameter here so you can call it different ways. That would really show managing complexity, right? Because you are omitting a lot of code you would have to write on top if you wanted to do different functionalities with different parameters that you can just do as one function. So think about that. This one here, out. The on event is inside the box. I just selected the whole thing. No, wrong. Now, if you just select this part, like they did up here, that works. Select the whole thing, no point, no credit, done. And then last but not least, this is really where you want to be. This is both by itself, and it's called twice, and it has a parameter. That really shows you how you're managing complexity, and you're calling it from different places. That's where you want to be, okay? So think about those two things. All right, let's talk about what you guys are actually going to be doing. The first thing you want to do is you want to think of your idea, and you want to make sure that you can do all the parts of the project with your idea. So you need to figure out, is there going to be an algorithm? Is there going to be some thing it's trying to accomplish? And then looks don't matter. As long as your program works, no one's going to judge how it looks, okay? So don't worry about graphics, worry about functionality. So let's see. For instance, if we were to do, let's say, a tic-tac-toe, right? Well, let's see. We don't want to make it too broad, so maybe you play against another player. That would be really easy, right? Then you don't have to write an artificial intelligence. Let's see. We want to make sure that the program follows all rules and allows X's and O's only in legal positions. So that should be pretty straightforward. Now, if you think about an algorithm we could have in here, we could have an algorithm that checks to see if someone won, right? And then that algorithm could have a smaller algorithm in it that collects data from each square or checks row, and then a different one that checks column. So there's different ways you can break this down. You guys see what I'm talking about here, right? And then you would want to have one of these, the larger one, to collect information or use information from two other ones to actually accomplish its task. And that would address all the algorithm concerns. So you guys can try these other ones. I'm not going to go through them because I don't want to belabor it. What you want to do is you want to make sure you have a clear purpose. You want to narrow it down. And you want to make sure that what you're thinking about, you can do with the programming skills you already have. You don't want to try to teach yourself some brand new, crazy thing during this project. That's not going to be a very good place to be. I highly advise against it. So there you go. Narrow it down. Think of some algorithms. And then, can you do it, right? You can get some feedback from a classmate if you like. I'm not going to require this. And then you definitely want to make use of this guy right here. Now, you'd have to either print it out or use text boxes to write on it, but the idea here is you want to make sure you have a purpose. You want to, as you go, note any difficulties or opportunities you encounter. So if I'm coding and I'm like, man, this is really hard, it's tricky, and then I figure it out, I want to make sure I write that down so I don't forget later, right? Before I start writing, you should do this section right here first. Identify what your main algorithm is going to be. And then what are the two included algorithms? How are you going to break that thing up in a top-down design manner? And lastly, an abstraction should be really, really easy to do. Just any function that you write yourself counts. Easy. Now, you do want to probably call that function from different places, so think about that. But the actual writing, really, really elementary. By the end of the week, what do I expect? I expect you guys to be done with these two boxes here. Hours 1 through 4. You should devote about 4 hours to working on this project. The week after, we're going to do hours 5 through 8. And then 5 through 8. And then the last week, we'll do 9 through 12. And then we will be done. That'll leave us finished on the 15th. The project is due to me on the 16th, which is a Saturday, so a day earlier than we usually submit things, Sunday. So please, please, please make sure you stay on track with this. You should begin your program and carefully monitor what you're doing, what your project thought process is, so you can write about it later. Please write down any problems or difficulties you're having. Make sure you have an algorithm and an abstraction all picked out before you start coding. Then you should be working and make sure you note things about those 2 points. And again, difficulties and opportunities. So, real straightforward. You need to submit your progress to me underneath modules, week 5 check-in. Simply take your code, copy and paste it by Sunday at midnight, and May 3rd. Please email me any questions or concerns. Once again, you are allowed to work with another person on this project, but only on the coding part. So if you would like to partner up for this, you certainly may. I'm not going to go out of my way for that and facilitate it, but if you would like a partner, you can email me and I'll try to set you up with somebody. All right, that's all I got. Have a great rest of your week. Stay safe and keep in touch. Have a good day.